So we're continuing with graphing graph of sine and cosine functions. Let's see, a general graph of a sine can be transformed up and down, side to side, can be squeezed vertically or horizontally, and we get any type of a just plain sine. Now, if I have a graph of if I want to graph a function of a sine of bt minus c plus d, it's nice to notice that the midline is just the vertical shift, y equal to d, is y equal to the vertical shift, which is y equal to d. The amplitude is what multiplies just the sine part. And then the period is the 2 pi divided by what multiplies t. And the phase shift is c divided by b. How do we graph such a function? So let's see. I start again with a t-axis and a y-axis. I know that that the midline has moved to y equal to 7, so I'm expecting around y equal to 7, let's say 1, 2, 3, 4, 5, 6, 7, up there to have a midline. Then amplitude, so midline, y equal to 7, midline. Amplitude is equal to 5. What else do I know? I know that the period is going to be 2 pi divided by 2, that is equal to pi. So basically, after, let's assume this is, let's assume this is pi, and this is 2 pi. And then the last thing is the phase shift. What does the phase shift mean? Phase shift is how much shift we get on the x-axis, or the horizontal shift. Let's calculate the phase shift. Okay, phase shift is pi over 6. So about this much. And here is 7 pi sixth. Okay, so from pi sixth plus the period 7 pi sixth, I should have one complete ripple of the sinusoidal wave. And so that's what I'm expecting to happen. If you remember, this was the plain sine function. This was pi, this was 2 pi, and it looked like that. So I'm trying to repeat that over here. At pi sixth, I will be at midline, which is y equal to 0. And then right in the middle between pi, after traveling 1/4 of the 1/4 of the period, I will be at the peak. Basically, peak is 1/4 of the period, and that would happen somewhere around, if I take the period divided by 4, which is pi 4, to add pi 6 plus pi 4 and figure it out, or I can just add and figure out where this 0 is happening again, which is happening right in the middle of these two, and then divide that by 2, and around here there should be a peak. So over here, midline is corresponding to that 0 moved 7 up. This 0 moved 7 up. This peak is in the middle, should move up 5 from that 7, because amplitude is 5. So going up, 1, 2, 3, 4, 5. And I have it right here. And again, the same story at 7 pi 6th, there should be, corresponds to this 0. 0 has moved up 7, so it's going to be right there. And then somewhere in the middle, there should be a lowest part. And lowest part is 5 down, which from 7 down makes it 2 down here. And then this repeats itself, and that repeats itself, and it goes on and on and on. So that's an example when you know the function and you try to graph it. Now let's try to give the next example. We're going to try to give the values for midline and amplitude and period and etc., and try to put actually a function that would follow those values. So continuing with the graph of sine and cosine functions, we often try to use sinusoidal functions to model something in real life. What is given in the problem usually is the average values. There's an amplitude, the period usually is given, and then they tell you what is the value when you begin. For usually at time t equal to 0, the value y equal to something. And so this is an overall feeling of how we have to model. And it's not a word, this does not appear like a word problem, but this is how you're supposed to simplify a word problem, extract the information that you need, like I did. You need to figure out what's the average value, what the amplitude would be, period, and a point on that to know the shift, basically the phase shift. And so from then, let's try to figure the A, B, C, D in this formula out. So I'm going to write down y is equal to A sine BT minus C plus D. If I figure out the average, I know D would be the average. The shift up and down is the average. That would be 12. If I know, and the next thing is that if I know the amplitude, I can replace A by the amplitude. The next thing I need to do is to find a period. How do I find a period? Period should be equal to the formula, 2 pi divided by B. So solving for B, pi simplifies from both sides. B is going to be equal to 14. So this is 14. And the last step is, this time I'm not going to use the phase shift. I'm just going to plug in the t equal to 0 and see what happens. Let's rewrite this. Y equal to 3 sine of 14t minus c. C is the one that I haven't figured out, plus 12. Now, if I plug in t equal to 0 in here, y is supposed to be 10.5. So let's do that. This is supposed to be 10.5. And this one is supposed to be, oh no, that one is okay. This is supposed to be 0. So what is coming down to is this equation. 10.5 is equal to 3 sine of negative c plus 12. Subtract 12 from it. So one thing that we want to learn when we're solving for trigonometric equations, we want to isolate the trigonomic equation, the trigonomic function, and that would be what we do here. So I'm subtracting 12 to get negative 1.5 is equal to 3 sine of negative c. Divide negative 1/2 divided by 3 is equal to sine of negative c. Negative 1.5 divided by 3 is equal to negative 1/2. Sine of negative c is negative sine of c. So sine of c equal to 1/2. This would give me what value, if I go back to the reference table, what value of c would give 1/2? Sine of c equal to 1/2. One of them is pi sixth. The next one would be 5 pi sixth, and so on and so forth. The only difference is here's pi sixth. The next one is 5 pi sixth. So there should be one extra piece of information to tell me whether the function is rising at t equal to 0 or falling at t equal to 0. Basically increasing at t equal to 0 or decreasing at t equal to 0. And then I decide whether to choose c equal to pi sixth or c equal to 5 pi sixth. So the solution to this could be two answers. Y equal to 3 sine of 14t minus pi sixth plus 12, or it could be 3 sine of 14t minus 5 pi sixth plus 12. If the value of y is rising at t equal to 0, the first one, value of y is rising at t equal to 0, then this one's correct. If value of y is decreasing, that was increasing, this one is decreasing at t equal to 0, this would be the answer. So this is an overall way of summarize your word problem into this sort of information if you need to model the word problem with a sinusoidal function. You need an average, you need an amplitude, you need a period, and you need a value. This could be the t equal to 0 could change to another t. But you need a value of y at some point. You also need to know if y is increasing or decreasing at that point to completely solve either for that sort or this sort of functions.